To start the project presentation update, this first part doesn't really matter, but I think it's interesting to see how coronavirus affected my project. So to start off, my project pulls data from TFIRS right here. And this is what the website looked like before we left for spring break. I came back from spring break and my code stopped working. And I'm wondering why is that? Because normally there's a roster filled out for each team where you get the information off of the roster, then get the individual's information. Because time has gone by, TFIRS now defaults to looking at the 2020 outdoor season. And somehow, because there is no outdoor season due to coronavirus canceling it, nothing fills out in the roster section. So it actually started my project again, had to write code to actually go back to indoor season, get this page, and then start it. But I've done that, and we're good. So the first main idea of my project was to create sort of a classifier based on what events you do and how many times you've done them to predict what event group you fall in. So I've done all the data work for that. So as a reminder, here is RPI's track and field graph. Anything in red is an event, anything in blue is the person who does them. As you can see, I've transformed it into a data frame where you have each athlete and then each event, and you have the number of times they've done that event. Now, one idea would be to instead of I stored the information as an edge attribute, one idea would be for each time you've done an athlete has done an event, add that many edges between the athlete and the event, and then this data frame I got would actually just be one section of the adjacency matrix. Because it's a bipartite graph, you would just take out one corner and you would get this information. But also, I went into RPI's website and got the year and the event group that every one of our athletes is in. So this is essentially the setup. This is our training data. This is our X, these are our labels. And here I have the years listed since I don't really know how to handle the year right now. You can see, for example, Camden Blake has thrown weight 23 times. Should it really matter that he's a senior and thrown weight 23 times compared to a freshman who's thrown it 7 times? It shouldn't really be weighted more that he's thrown it 23 times. So I'll have to find some way to incorporate the year into the classification. One idea may be just take this whole matrix and divide the row by what year you are. Or another idea may be just add the year as a feature into the training data. And another problem introduced by coronavirus is what to do with freshmen. Because freshmen only got an indoor season. And so I don't really know if there's going to be any value into adding freshmen and learning on them. It may be better just to look at freshmen only and compare to other RIT freshmen only, or look at things as a whole or weight freshmen differently. Either way, it'll be something to figure out. So in addition to this is our training data. Let's see. Images. And here is our testing data. The plan is to train on RPI's graph, and here is RIT's graph. There's still one similarity in that there's a throwers group over here, though RIT seems to have a bigger pole vault program and more people doing the heptathlon close to the throws. So again, the goal would be I have this data for RPI, I have the same data for RIT, and now we just have a classic multi-class labeling problem. And so my other question was essentially a set cover problem, where again we want to see how many athletes do we need to cover all of the events. And so I have that data too. You can get it pretty simply by this right here is the whole set of possible events. This is one of the bipartite sets. And here you have an athlete, and their set is just all the events that they've done, which you can simply get from the graph. One problem we'll have to tackle, as showcased here, is the multis, the people who do heptathlon and decathlon. I don't think it's really fair to count that because one person does the decathlon, they have done 17 events here, when really 10 of them are just for the decathlon only. So I'll probably solve a version with and without that, we'll see. So again, the update is my project's going pretty well. I have all the data set up, and the next step is to create some sort of classifier on this data, and then for this, simplify it down to minimal sets. For example, Marty Bond is a subset of Camden Blake, so we know he's not in the optimal solution, so we would remove him and move to a smaller set. And from there, we would run the greedy algorithm and then also try doing all possible combinations.